Right, another topic related to Lewis structures is this concept of a formal charge, and whenever there's a possibility of drawing the Lewis structure in two different ways, then you would look at the formal charge and determine which of the Lewis structures is most likely. And so to find the formal charge, we would take the number of valence shell electrons that the neutral atom would normally have, subtract all the lone pair electrons that are around it in the Lewis structure, and then assume that half of the bonding electrons are associated with that atom, and then divide that number by 2 and subtract those. And let's look at CO2. So before we came up with this as our Lewis structure for carbon dioxide. And that's what we said the Lewis structure was, but there are also a couple other ways that meet our rules, right? This could be a triple bond, and then this could be a single bond, like that. And that would make everybody C8 electrons. The third possibility is, right, you could have oxygen in the center, like that, and then we would have bonds here and here. Here. Right, so there's kind of 3 different ways we could write this out. And so to figure out which one makes the most sense, we want to find the formal charge, because if we have a molecule with all zeros for the formal charge, that is preferred. If we can't find one where they're all zeros, then the smallest non-zero formal charges are preferred, and then adjacent formal charges are 0 or of opposite sign is preserved, and then we kind of move on from there. So let's look at the formal charge is on these 3 atoms in this molecule. So we take the number of valence shell electrons for the neutral atom. So oxygen is in group 6, so it would normally have 6 valence electrons around it. Then we're going to subtract the number of lone pairs electrons, so there's 1, 2, 3, 4. And then we have 2, 4 bonded electrons, and we're going to divide that by 2. All right, so we have 6 minus 4 minus 2, which equals 0. So the formal charge here would be 0 for that oxygen. And to save us some calculation time, this oxygen is equivalent, so it's going to be 0 as well. Now if we look at the carbon, right, carbon is from group 4A, so it has 4 valence electrons normally. In this case, how many lone pairs? There are no lone pairs on it, so we're going to subtract 0 for that. And then we have 2, 4, 6, 8 bonding electrons around it, so we're going to subtract half of that. And that's going to give us 0. So this configuration has all 0 formal charges, which is our preferred setup. All right, so now if we come over and find the formal charge here, we have oxygen again. It's going to have 6 valence electrons normally. Here it has 2 lone pairs, so we're going to subtract 2, and it has 2, 4, 6 bonding pairs, so we're going to subtract half of those, right? So we have 6 minus 2, 6 minus 2 minus 3, so 6 minus 5. So we have a plus 1 formal charge on that oxygen. Carbon normally has 4 valence electrons. It has 0 lone pairs in this configuration, and then it has 2, 4, 6, 8 bonding pairs. So we're going to have 4 minus 0 minus 4. So that carbon has a formal charge of 0 on it. If we move on to that next oxygen, it normally would have 6. It has 2, 4, 6 lone pairs, and it has 1 bonded pair, so 2 divided by 2. So we have 6 minus 1. So we have negative 1 on that formal charge, on that oxygen. So this configuration would be preferred to that configuration. If we look at our third setup, right, we've already done this oxygen with 2 double bonds. We know that's going to be 0. if we have this oxygen in the middle, it's going to be 6 minus 0 because there's no lone pairs. It has 2, 4, 6, 8. Bonding pairs, we divide that by 2. 6 minus 0 minus 4 is 2. So we have a +2 formal charge there. If we look at that carbon, it would normally have 4. It has 2, 4 bonded pairs. I mean, 4 bonded electrons. 4 non-bonding electrons. Let's keep trying. So 4 lone pairs, 4 lone pair electrons. 2, 4 things bonding electrons, divide that by 2. So we have 4 minus 4, 0 minus 2 is a -2, right? So we have larger formal charges here. So this would be the preferred, this would be the next best, and this would be the last choice for how that configuration looks. And so this would be, again, the preferred. And you should also notice that the sum of all the formal charges has to equal 0 because there is no charge up here. So really we're just counting electrons again and trying to see how many are associated with the different elements.